In addition, since Unity 4.x, two animation systems are available: the legacy and the mechanism system. Finally, full use of animation requires scripting to ensure that animations are run at the correct time or event. Animation simply comes down to the fact that certain attributes or properties change over time. When a game object changes its position frame by frame, it is animated. Some animations are created on the fly, like moving around or turning a camera, while others are defined in advance, like the body motion of 3D characters. Pre-recorded animation is stored in clips, and they are assets, files, that are stored in the assets folder. The original third-person controller from the Character Controllers Unity package was set up with the legacy system, whereas the new one uses mechanism. Legacy animations are kept in an animation component, which references animation clips of the legacy type. For instance, idle, walk, jump pose, and run. This component also provides a default clip that can be launched when the game starts, if the Play Automatically option is ticked. To toggle the other clips, scripting is required. When you select a single animation clip, it is tricky to check whether it is a legacy or a mechanism clip. When you only see a few parameters in the inspector, you have a legacy animation clip. This is rather important as the animation component only accepts legacy clips. On the other hand, when you create new animations, by default they will be of the mechanism kind. Go to Game Object, Assets, Create Animation. In the inspector, you see several additional properties available. And when you drag the new animation clip onto an object, Unity will not add an animation component, but rather an animator component, and also create a new asset with the name of the object, an animation controller. This controller can be configured in a more graphical way and can be used to define multiple animation clips that need to be triggered and blended together. This is where you set up the mechanism animation system. Beware that it goes much further, especially when you set up moving characters, but this is beyond our scope in this video series. And finally, to do something more elaborate, like to play different animation clips in different situations by reacting on key presses, this requires scripting. In this video lesson we did not really do much, but we defined the basic terms for animation and pointed out the two different animation systems available in Unity. In the next video, we will actually create an animation from scratch, when we make a cube rotate automatically. This is the second video of section 5 on animation. In this video, we explain how we can define an animation clip to make a cube rotate around in a looping mode. We will create a new animation clip and assign it to a game object. We will then refine the actual movement in the clip to better set how the movements will be performed. This is using the widely known keyframe method as used in Adobe Flash or other animation software. You define main animation keys at particular frames and the computer will do the interpolation between these keys. In Unity, we start simply with a single cube game object, positioned at the world origin and without any rotations set. This is rather important as these values will be steered by the animation clip, replacing whatever value is set manually. Please remember this. Create an Animations folder in your Project tab and open it. Now call Assets Create Animation in the menu, and when the new asset is displayed you can directly type a suitable name. Call it Rotation Loop to indicate what we want to use it for. Now drag the animation clip we just created onto the cube object in the scene view. Two things will happen. The cube object receives an animator component, and a cube controller asset is created. The controller is automatically assigned to the animator component and ensures that the new clip will act on the cube game object. With the cube selected, open the Animation tab from the Window menu. This opens a new floating panel, which you can dock wherever you want. The rotation clip is already visible, ready to start recording animations. Right now, nothing will happen when you press the small play button on the Animation tab. We need to add one or more animation curves first. Press Add Curve and browse to the rotation entry underneath the transform to press the plus icon. Once a curve is added, you can fold out the rotation line and look at the rotation Y parameter. It has two keys already defined, indicated by the small diamond shape on the timeline. The red line is a time indicator. Drag the time indicator to the last key position or use the forward-backward buttons to ensure you are adding the rotation Y value at the right time. Set a new value to 360 to ensure the cube is performing a full rotation over the indicated time frame of 2 seconds. Internally, Uni samples these animations clips at 60 frames per second. Press the small play button to check that the cube is effectively rotating. To fine-tune the animation interpolation, you can toggle the curves display mode, which gives a graphical view on how the parameters evolve over the time frame. In this example, we get a linear interpolation between 0 and 360 degrees, which works fine for a continuous looping rotation. We can now play the game and see our cube rotating once in the game window. To make it loop, adjust the animation clip properties in the inspector and activate loop time. Press play to confirm. In this video lesson, we created a new animation clip to make a cube rotation around its y-axis. In the next video, we will expand this to have a nice door opening animation with smooth transitions. This is the third video of section 5 on animation. In this video, we set up and keyframe a simple door that opens smoothly using an animation clip. Our door will be a simple cube, but we need to add an additional object to act as a hinge. This way, the animation clip will rotate the hinge and the door will follow automatically. Our setup is very simple. We create an empty game object called hinge in the origin. Create a cube game object and call it door. Drag the door onto the hinge so it becomes a child. All we need to do now is position and scale the door to ensure its corner is in the same place as the hinge. We need such a setup, as otherwise the door would rotate around its own center instead. To test if this setup is working, you can rotate the hinge around its y-axis. The door should follow the rotation, but around the hinge instead of around itself. Before we create a new animation clip, ensure the hinge is selected and not the door. Press Add Curve and add a new curve for the rotation parameter. To have a smoother animation, we will add a few different keys. We need at least 4 of them for the different positions. Right before opening, reaching completely open, right before closing, and fully closed. Use the Add Key button and move the keys to adjust the speed of the movement. Now we can set the values for the rotation Y parameter at 0, 90, 90, and 0 respectively. If you press play now, the door opens, stays open and closes again, but rotates a bit too far. The automatic interpolation can be seen when we switch to the curves display mode. To ensure the door stays cleanly at 90 degrees when open, select a key, the yellow dot in the view, and right-click on it to define its tangent direction. Set it to flat for all 4 keys. Now press the play button to test how the door animates more smoothly. It looks fine, but right now it immediately opens again after closing. We will return to this problem later on when we introduce scripting. In this video lesson, we got our hands on the actual animation curve of the door and adjusted it for a nice smooth transition between closed and open. In the next video, we will create a simplified elevator setup with 2 sliding doors and a rising platform. This is the 4th video of section 5 on animation. In this video, we expand our animation capabilities by setting up a construction with multiple moving objects. We start with 2 doors that need to slide open. The trick is to attach them to a single parent object, which will contain the animation for all its children. The platform is also added to this setup in the next step. First, the main setup. Create a box for one of the doors. Call it sliding door and scale it into a door. Duplicate it using Ctrl or Command D and position the 2 doors side by side. Keep the origin at the bottom corner between the 2 doors. Attach them both to an empty game object called elevator. An additional box is needed for the platform, which is also parented to the elevator. Now create a new animation clip called Elevator Animation. And drag it onto the elevator to link it and automatically add a controller for it, which will be named Elevator. Select the elevator game object and add curves for the transform position parameters of its 3 children. We add keys to define a movement in the x direction for the 2 doors. We start at x equals minus 0.5 and plus 0.5 respectively. And they slide 1 unit or 1 meter to minus 1.5 and plus 1.5. And then return to the start. Drag the keys far enough onto the timeline so the animation will be slower, taking more frames. For instance, 2 full seconds between each key. Just as with the door from the previous video, we need to set a tangents to flat for a correct movement. The platform will start to move after the doors have closed, so continue to add keys to the platform position at later time frames. Set position Y at 0 after the doors closed and at 2.0 a few seconds later. Don't forget to set the tangents to flat as well. Now you can play the full animation and adjust the position of the keys in the dope sheet view to tweak the timing properly. This is not a fully finished elevator, as there would be additional doors when we arrive at the next floor, but this explains the basic setup of a more complex animation involving multiple objects. In this video lesson we made a very basic elevator with 2 sliding doors and a rising platform, all attached to a single elevator object. The Animation tab gave us precise control over timing and interpolation type. In the next video, we will finish our animation introduction by creating a sun or shadow study. This is the fifth and last video of section 5 on animation. In this video, we create a sun study by animating a directional light with shadows. The animation of the sun's orientation, the altitude and the orientation, is made more intuitive by linking the directional light to a parent object, which will receive the orientations. We will also animate the light color to improve the mood differences between morning, noon and evening. We start from a basic scene with one of our architectural models. Create an empty game object in the origin and call it Sun. Add a directional shadow casting light and call that Sunlight. Position it at x0, y0 and z minus 10. Make the sunlight a child of the sun. The positioning of the sunlight is technically not necessary for lighting, but it makes the setup easier to understand for the scene editor. If you now rotate the sun using the x value for altitude or height and the y value for orientation or azimuth, you can see that the sunlight nicely follows the movements. Create a new animation called Sun Study and drag it onto the sun to create a controller and link them together in one step. Create the rotation curve for the sun, not the sunlight. Now set up the keys. Set x to 0 and y to minus 90 at the time frame 0. X to 45 and y 0 after 150 frames, that's about 2.5 seconds. And x to 0, y to plus 90 at 300 frames, or 5 seconds. When we play it, we see the sun describing a circular movement around the scene. To define our sun study, we can also animate our sunlight color. Add an additional curve for sunlight for the light color value. Set the color at time 0 to a dark orange. Apply a bright yellow at the second key. Finally, a dark purple at 5 seconds. This mimics the shift in hue and brightness throughout a typical day. Again, when you press play now, you get the animated sun with its moving shadows, but only once, as a default for an animation clip is to not loop. One thing we did not cover here is that imported models can also have their own animation clips. The third-person character model is a good example, but you could also prepare opening doors or more complex movements, such as an escalator, directly in your 3D animation software. In this video lesson, we created an animated sun, where not only the position of a light changes, but also its color. This completes our section on animation. The next section will introduce you gently into scripting.